Hello, AI Wizard here. In the last video, we covered the details of what happens when you go to your AI chat like ChatGPT and then drag and drop your PDF to chat with your PDF. There is an entire process that we covered, and at the end, we concluded that we extract the information and then we save it to context window. So then AI chat will be able to retrieve that information based on the context window. And essentially, it's the same as if you just copied the entire text of PDF and just send it as a message to AI chat, all right? So for example, if we have some PDF with recipes, you can just copy the entire text, send it to AI chat, and then it will know the information about those recipes. And the video will be in this video's description, or you can just watch our latest video. You'll be able to find it. Now, there is a problem. Oops, we have a typo here. There is a problem. The context window is limited in size. And I'm not going to go into details why it's limited. You can just think that AI chat might not remember the information that you sent about your PDF the more you chat. So for example, the longer your chat is, the more likely that AI will forget about your PDF. And you can even try it now if you go to ChatGPT and send some PDF, send some other files, and then keep chatting with it in the same chat, you will notice how the performance degrades. It starts to forget things. Now, how do we avoid that problem? I'm going to spoil it for you. We would need to save this text into some storage, and we can call it a database. Or more precisely, maybe you have already heard about it. It's called RAG, which means Retrieval Augmented Generation Database Storage, okay? So it's just a place where we store that text from which AI will be able to on demand receive the data. However, I'm going to cover the specifics of how we store that text into RAG in the next video. Today, I'm going to explain one prerequisite term that we need to understand before we can even cover how do we save that PDF into RAG, okay? So let's remove RAG first, and that prerequisite term is called embedding, okay? So now, what is embedding? Okay, I'm going to go into high-level overview. Again, if you want me to go into more details, more technical details, you can let me know in the comments. Embedding is basically a way to represent our text in numbers. Okay, why do we need numbers, right? So I'm going to explain on the PDF example. So let's imagine we have a PDF with recipes, okay? And then, for example, it would have sections. So we would have, this is a recipe for banana pancake. Okay, so then maybe this is a recipe for Japanese ramen. Okay, and so on and so forth, right? So we can have a bunch of these recipes. Like, just imagine there is an entire recipe for each of these sections. Okay, so the PDF might be quite large. It can be an entire recipe book. Now, let's say we already extracted this text, okay? So this part doesn't go away. And again, I will cover the details of how we exactly extract text for storage later, but imagine that we already extracted the text. One problem here is that if it is in the context window, technically AI will be able to look at all recipes at once. But again, that might not be possible. What if the context window is very small? What if we have a lot of chats? AI will have to keep up with a lot of data. Now, in that case, okay, we'll move this text into some separate storage. However, how exactly we are going to find the information? So see, if we move this text into some separate storage where AI will be able to retrieve the data on demand, because we don't want to overfill the context window, it will be getting only one of these, not everything. But the problem, if it gets only one of these or some of them, it needs to find them first. Now, how can it find some information? So usually, the most basic approach, it will search by keywords. So for example, we can search for specific keyword banana. We can search for specific keyword ramen. However, there might be a limitation. Why? Because some dishes, for example, in our case, some recipes might be called, so for example, we can call it noodles. Now, you as a human, you might understand that ramen and noodles might be related to each other in some way. However, if you are doing a keyword search, in that case, let's say we specifically search for ramen, we will only see this recipe. We will not be able to see this recipe. However, you know how when you go to your Google or even chat with ChatGPT, you might not necessarily type the exact keyword that you are looking for. You are expecting those programs to understand your intent, your meaning of what exactly you are trying to search for. And for that reason, we need to create embeddings of these texts. Now, embeddings are basically a numerical representation of your text. Now, what does it mean? So for example, let's take a word noodles. We can assign a number to a word noodles. So let's say noodles. And then we'll assign it a number, just 1, 001, all right? Now, we can think, just kind of guess, assume, ramen is related to noodles. It is related in some way, okay? Because, well, ramen is usually made of noodles, all right? Now, how far ramen is from noodles in terms of the relation? We can try to kind of assume, and let's just assign it a number of 10. So we say 0, 10. So there is kind of 10 steps between noodles and ramen, right? So for example, we can also add pasta here. So pasta and noodles are kind of close to each other in terms of relation, I would say. So let's assign a number 3 to it, because it's only 2 steps from each other, all right? It's not that far. I'm sorry, my Italian friends, but it's not that far, okay? Maybe the second would be spaghetti, for example, right? So now these numbers are basically representing words, and they are also representing the relationship between these words. So that's basically what we kind of call an embedding. And that's why we need to create it. So now imagine, okay, let's compare, right? So for example, you as a user are trying to search for something. And you are trying to search for a specific way to make some noodles. Let's say, imagine you are trying to prepare your own noodles from scratch, right? So then you are searching for, let's say, recipe for what kind of noodles there are, thin noodles, okay? Just let's just say that. You know what? I just rethought an example. Okay, so let's just say we have noodle soup here as well, right? And we can say that it's kind of related to ramen. Maybe we assign it a number of 15, okay? And then you are searching for a recipe for thin noodles soup, for example, all right? Now, if we are doing a keyword specific search, all right, we might search maybe for thin noodle soup, And technically, out of these words, we will not find anything. We are not able to match anything because notice how we have thin, noodles, and soup. So the way the program works, right, the way that traditional search works is that it needs to match exactly this. But there are no three words here at all. We don't have thin, we don't have noodle soup, for example. We don't even have that. Notice how it says noodle soup, not noodles soup. So we will not be able to match the exact result that we want to get out of these words. So just imagine all of these are recipes, right? We can just imagine that. Now, how AI will be able to find those then? So if we do search on embeddings, the way that it will try to search, whenever it searches, it will attach a semantic meaning to it, which means that by searching for this, it will find the noodle soup. Then it will also be able to see that it kind of relates to ramen, and it will able to pull the results for recipe of the ramen and noodle soup. Now, once it gets those results, the AI is smart enough to understand that you are probably searching for ramen, okay? It might ask you what kind of soup are you looking for, what kind of noodle soup are you looking for, maybe you're looking for pho, but most likely it will just give you the ramen. Why? Because although you are saying noodle soup here, it kind of understands your intent. And because it can kind of match that, okay, we have noodle soup as 15, and then we also have like very related ramen recipe. It will understand that, okay, most likely you are looking for ramen recipe, okay? Because in this example, we have a bunch of recipes, but we don't have like any more other noodle soup. For example, if say we had something like pho, okay? And let's say assign number 12. Kind of related to ramen, kind of related to noodle soup. In that case, it will actually pull out pho as well, because again, it will find this noodle soup, but it will find that it relates closely to pho and ramen, and that's most likely what you're looking for. And basically, why do we even need to convert to the numbers is to be able to quickly search what word relates to what word logically, semantically, what kind of relations do they have? So in other words, let's just redraw this part. So that's how it will look like. We'll have noodles, then we'll have pasta, then we'll have ramen, then we'll have pho here, then we'll have noodle soup. And these guys, they're all connected to each other. So all of these are connected to each other. Now, there is also a very like kind of further, like let's just put it like further away. We have like a much further connection to pasta and noodles as well, okay? So in this case, when it finds the noodle soup, because well, that's what you are asking kind of, it will see, oh, the closest location that I have is pho. And then after pho, the closest location that I have is ramen. And then there is nothing close to ramen. It's kind of far away. This entire representation is called dimensions. And that's basically how the data is stored. Like if I explain from high level abstracted overview, that's basically how the data is stored. And to be able to basically understand how far the word is related to another word. That's the reason why there are numbers, because it's basically assigning these distances kind of based on the numbers. It knows what kind of number is related to what kind of other number, okay? And these numbers are close to each other, they're related, therefore it will understand that you're looking for recipe from somewhere here. And then it will kind of try to do educated guess on what exactly you are looking for. Maybe it's in noodles more related to pho than ramen. So it will just pull out the recipe for pho, and maybe it will ask you, hey, maybe you want ramen recipe, or maybe you want some generic noodle soup recipe as well. One of these is probably something that you're looking for, because again, you might not know the specific name for ramen, for pho. You might not know these dishes, but you know it's kind of like a noodle soup. So you might search for noodle soup. You don't have to specifically say, I'm looking for recipe for ramen. You can just say, hey, I'm looking for a recipe of noodle soup, like just pull out some data, right? And it will be able to search and find those. Like in comparison, again, the traditional search, it will kind of, you have to have a specific entry saying noodles soup in your recipe book, but it might not be the correct one that you are looking for. It might not be able to find those. So for example, like in this example, right, we don't have noodle soup here, so it will not find anything, but we do have a recipe for Japanese noodles and Japanese ramen. So probably you are looking for one of those, right? And with this approach, it will able to find the relationships between all the words that it's looking for, and therefore it will able to pull up the recipe for Japanese ramen. Another thing, important thing. So whenever AI searches for this, so this data, it's stored somewhere else. It's basically stored in RAG. Again, I will cover that in the next video, so stay tuned. But imagine this data is not in the context window. Only when it finds something, because AI will be able to kind of search through this storage, it will be able to see, ooh, okay, we have noodle soup. Ooh, okay, the pho is related. Ooh, okay, ramen is related. So it will pull only these three into the context window, which means we don't have to pull our entire recipe book into the AI chat, which means only parts of PDFs will be accessible for AI. And then if it needs to, it will search for another parts depending on what you are asking it to. And basically, that's what is embedding from high-level overview. And again, keep that in mind, because in the next video, I'm going to explain to you exactly how do we extract text from PDF and then convert it to embeddings and then store it into RAG. So stay tuned. Hello guys, this is AI Wizard from the future. So after I watched the video, I think it might not have been that clear, again, what is embedding and what is the role of embedding. So let me just give you one last example here, okay? Bear with me. Now, let's say a buyer comes to the tool shop and says, I broke my hammer and I need a tool for nails. So let's say the buyer says this, right? And then we have a seller that would be the person who would basically go and search for the tools. Now, the core part of what buyer is asking, I need a tool for nails. Now, seller is a human. So he or she is smart. They know that they probably are looking for the hammer because the context is here. It's very clear for a human that the buyer is looking for a hammer, and then the seller just passes the hammer to the buyer and everyone is happy. Now, unfortunately, if we replicate this scenario and then we are going to call the buyer a user of computer. So computers, they're not very smart. When you say, I need a tool for nails, what they understand is tool for nails. And unfortunately, if you go to the shop and try to search for tool for nails, traditionally, because computers are searching for tool for nails, maybe it will see a hammer, maybe it will see an axe, it can see saw, it can see a lot of different kind of tools, but nothing is tool for nails. The name of these tools is not specifically saying tool for nails. It might say hammer again, and yes, the human might know that, okay, hammer is a tool for nails, but computer doesn't know that hammer is a tool for nails. Now, that's why we are creating an embedding, because in embedding case, the tool for nails will be numerically related to the hammer. It can be from very far. For example, this might be related to something else, like axe. And in this case, computer can see, okay, I'm looking for a tool for nails. Okay, there is a hammer, which is very close. So let me put and get both of these. And it will just give both of these here, okay? Axe is very far in terms of relations. Again, numerical representation is very far from being a tool for the nails. And therefore, it will ignore the axe and bring these two. And remember, because we are talking about AI systems here, beside computer, there would be an LLM, right? AI LLM, AI chat. And what will happen is that computer will again find tool for nails. It will also find the hammer because it's very close in terms of relations, semantic, logical meaning to it. And then it will pass it to LLM. And then LLM will basically see the entire text because LLM is more smart compared to traditional computers. So it will say, oh, okay, I think this user wants a hammer because we do have a hammer here. We do have a hammer in our shop. And it will basically provide an answer. It will basically give the hammer to the user. Okay? Now, you might ask, why LLM just don't and go directly search for this? Okay, so all of this is basically tools that are stored in the shop. And LLM by itself is not able to access the shop. Or as we said, we might not want to allow LLM to access the entire shop because the LLM's context window is limited. So it needs to do a search. It needs to find the specific thing that the user is looking for. And it does it so through some logic, some program logic that is built by other like software developers. So basically a computer to find what it's looking for. And LLM, it knows that it's looking for a tool for nails. So it will basically say, hey computer, can you find me a tool for nails? And then also give me all the closest related words that are matching tool for nails. And then it will just go ahead and computer will go ahead and find tool for nails. And then it knows, oh, hammer is very near. So let's just grab a hammer as well. The axe, okay, on the other hand, is very far. So we are not probably going to pass axe back to LLM. So then computer will basically bring these two to LLM. And then LLM will check, okay, I have tool for nails, I have hammer. Okay, I think because the user just now told us that they broke their hammer, they probably looking for a hammer. Okay, and because it's also related to as a tool for nails, it will definitely confirm that it's a hammer. Again, LLM is a smart guy here, okay? It's just that the computer is not very smart. So therefore, we need to kind of embed whatever tools we have in the shop so that computer can help LLM to actually find those. Now, this is traditional normal logic that we have, okay? So, and the tools that have relations between them are embeddings. So if let's say these tools did not have relations and they would just have like, they would be just on the shelf next to each other, this would be just the data, just information, okay? Now, once we embed them, we will create the relations like so, because of the numbers that we'll assign to them. So this would be 1, this might be 2, it's very close to each other, and then this might be 10. We can think about it as a distance. So for example, this would be, let's say, 1 meter apart. So tool for nails and hammer would be 1 meter apart, while axe would be 1 kilometer apart. Okay, so it's very far. It's not what we're looking for. We are looking for this group, which will be passed to LLM, and LLM is the smart guy here, so it will understand, okay, probably from these two, we're specifically looking for hammer, and then we will return the hammer. Okay, So I hope this example is more clear. Together with the entire video, I think it concludes it very nicely. If you are still not clear, just let me know in the comments. I will try my best to explain to you in a better way. Okay, bye. And as usual, if you guys are interested in AI and you are working in finance industry, for your company, for your professional use case, we have a specialized AI agents for finance industry. Go to our YouTube profile here, click on this URL, book a call with us. Thank you. Bye-bye.